Section 7.2, Rational Exponents. When defining rational exponents, we want the rules for exponents to hold for them just as they do for integer exponents. A to the 1 over n means the nth root of a. When a is non-negative, n can be any natural number greater than 1. When a is negative, n can be any odd natural number greater than 1. The denominator of the exponent, and here's the denominator of the exponent, is the index of the radical expression. So if we have a to the m over n power, this means that we are taking the nth root of a to the m, or we are taking the nth root of a raised to the m power. And let's look at some examples. They're asking us in these first ones to write as radicals and simplify as possible. We have 64 to the 1/4 power, which means that denominator of our exponent is the index of the radical. So this is equivalent to the 4th root of 64. Can we simplify that? Is there a number times itself 4 times that gives us 64? Well, since 4 times 4 times 4 times 4 is 64, the 4th root of 64 is 4. Because it's an even index, we're always after the principal root, which is positive. In this next problem, we have 27 to the 4/3 power. The denominator becomes our index, so we're after the cube root of 27. And instead of raising it to the 4th power underneath the radical, since 27 is a perfect cube, the alternative is take the cube and then raise it to the power, rather than having to take the cube root of 27 to the 4th power. Simplifying this, a number times itself, that gives us 27 3 times is 3. Because we're taking an odd root of a positive number, the root will be positive, so it's a positive 3, and that's now needs to be raised to the 4th power, which gives us a final value of 3 times 3, which is 9, times 3 is 27, times 4th 3 gives us a value of 81. In this next problem, when we write this as a radical, again, the denominator of your exponent becomes the index of the number. And similar to the last one, instead of taking the cube root of something raised to the 5th power, we'll put off that power until after we've simplified the index or the radical. The index being odd of a negative number means we will have a negative result. What times itself 3 times gives us -8? That would be a -2. Since -2 times -2 times -2 is -8, now we'll raise it to the 5th power. A negative raised to an odd power is negative, and 2 times itself 5 times gives us a value of 32. X to the 1/8 power, as a rational exponent, the denominator becomes our index, and since there is only x to the 1st power, there's nothing that we can do with this problem. The last example here, we have a quantity raised to the 1/5 power. Simplifying that, our rational exponent, the denominator becomes the index of our quantity, so we're taking the 5th root of x to the 4th times y to the 2nd. Neither of these powers in the radicand are higher than our index, so we can't simplify that either. Then, going the other direction, these problems are asking us to write an equivalent expression using exponential notation. What is the index on this first problem? The implied or assumed is the square root, so this equivalently would be x to the 1/2 power. The cube root of a would be a to the 1/3 power, using the index as the denominator. Next, we have the 4th root of y to the 3rd. The index becomes the denominator of the power, so this would be y to the 3/4, where that denominator is the index on the exponent. Next, we have the 6th root of 2x raised to the 5th power. We can simplify or replace the radical in the parenthesis with an equivalent expression using exponents, so it would be 2x raised to the 1/6 power, takes care of the radical, and then it's raised to the 5th power. When we have a power raised to a power, we multiply our exponents together. 5 has a denominator of 1. When multiplied by 1/6 gives us 2x to the 5/6 power. And the last example is asking us to replace this radical with exponential notation, and very similar to the last one, we're replacing the 7th root, which means that radicand will be raised to the 1/7 power. And then looking further, that quantity is raised to the 3rd power. When we have a power raised to a power, we multiply our exponents together. 1/7 times 3 leaves us with the quantity 3x squared y to the 3/7 power.